This is the second part of frequency distributions, and in this lesson I will explain to you the concept of group frequency distributions. In the last lesson I have explained to you the categorical frequency distributions, while in this lesson we are learning group frequency distributions. So when the range of the data is large, if suppose we have a large amount of data, then we will use group frequency distribution. And group frequency distribution is the organizing of the raw data. And what is the meaning of raw data? The data which we obtained initially is called the raw data or primary data or the source data. So we organize the raw data in the form of table using classes and frequencies. So this is called the group frequency distribution, and the largest data value that can be included in a class is the upper class limit for that class, and the smallest data value that can be included is the lower class limit. Now what does it mean? It means suppose we have a large amount of data and we are making the classes and our width is 5. So first class is suppose 10 to 15. So 15 is the largest data value that can be included in the class, is the upper class limit of that class, and 10 is the smallest data value, which is the lower class limit of that class. And I will explain to you in the next few slides these with the help of examples. And class boundaries separated the class. So when we will make the group frequency distribution, we have to keep these points in mind. So first you have to find out the largest value and the smallest value, or the maximum value or minimum value from your data. Suppose we have 1,000 numbers in our data and the smallest value is 10 and the largest value is suppose 990. So smallest is 10 and largest is 990. First you have to find out these two. Then we have to calculate the range. So range is maximum minus minimum or largest minus smallest. Right, in the first step we have found the smallest value and the largest value. So here we are using that values in order to calculate the range. Maximum is 990, minimum is 10, so our range is 980, and this is just the example. Third point is select the number of classes desired, and this is usually between 5 to 20 classes, and this is not the hard and fast rule, it's up to you. Then we will find out the width of the class. This is the important point. And how you will find out the width? By dividing the range. See, we have calculated the range in second step. The maximum minus minimum value is called the range, and you have to divide the range by the number of classes. Suppose we have decided 5 classes or 6 classes, so range divided by 6 or 5 by the number of classes and rounding up. To find the upper limit of the first class, subtract 1 from the lower limit of the second class, then continue to add the class width to this upper limit to find the rest of the upper limit, and I will explain this point in the next slide with the help of example, then it will be more clear. And then boundaries, how we set the boundaries. Find the boundaries by subtracting 0.5 unit from the lower limit. Means suppose our lower limit is 10, so we have to subtract 0.5 from the lower limit. Our lower limit then boundary will be 9.5, and suppose if our first class is 10 to 15, so we have to add 0.5 to 15. So first boundary will be 9.5 to 15.5. And boundaries are also halfway between the upper limit of one class and lower limit of the next class, depending on what you are trying to accomplish. It may not be necessary to find out the boundaries. It depends what type of graph you are making, what type of conclusions you are making. So on the basis of your question or the basis of your need, we make the frequency distributions, and then we make the tally sheet, tally the data, find the frequencies, find the cumulative frequencies and the relative frequencies. Again, these are not necessary, but it depends what you are trying to accomplish. This is the example. Suppose these are the ages of 54 people, and this just assumptions, the data is not real. And in this example, suppose we are considering 9 classes. So see, these are the 9 classes: 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is the raw data. On the basis of this data or these numbers or these ages, we cannot make any conclusion. So we have to arrange this data in a groups, then we will make a tally sheet, and then we conclude with the help of table what we have made. So first you have to find out the smallest number I told you in the previous slide, which is 23, and the highest number is 85. Then second point is we have to find out the range, and the range is maximum minus minimum. 85 minus 23, which is equal to 62, is the range. And then width of the class, 62, range divided by number of classes. So our number of classes are 9, so 62 divided by 9, which is equal to 6.88, approximately equal to 7. 7 is the width, and this is the rounding rule of width. Rounding rule, always round up if the remainder is there. So is the remainder 6.88, so we will round up. We will not round down, round up. It will be 7 width. Suppose if it is 3.12, so we will round up, that will be 4. If it is 5.3, we will round up, that will be 6. So this is the rounding rule. So the smallest value, 23, our first class limit will start from the lowest value and end with the highest value or maximum value 85. We will choose the lowest data value 23 for the first lower class limit. The subsequent lower class limits are found by adding the width to the previous lower class limits. Now what does it mean? It means, see, 23 is the lower class limit, 30th is the lower class limit, 37 is the lower class limit of the third category. So you have to add the width, and width is 7. 23 plus 7, 30. 30 plus 7, 37. 37 plus 7, 44, and so on. And this is the upper limit. So the next upper limit, same thing, 29 plus 7, 36. 37 plus 7, 43. 43 plus 7, 50, and so on. And this upper class limit is 1 less from the second lower class limit. Second upper class limit is 1 less from the third lower class limit. So see, the first upper class limit is 1 less than the next lower class limit. The subsequent upper class limits are found by adding the width to the previous upper class limit. And then we will set the class boundaries. And I told you that class boundaries, you have to subtract 0.5 from the lower class limit, that will be 22.5, and add 0.5 to the upper class limit, which is 29.5. Then is 30th, you have to subtract 0.5 from the lower class limit, that is 29.5, and then add 0.5 to the upper class limit, which is 36.5, and so on. The class boundary is midway between an upper class limit and the subsequent class limit, and then we will make the tally sheet. This is the tally sheet. By then we will count the tally sheet. These are 4, so 4 frequency. This is 5, 6, 7, 7 here, 4, 10, and so on, at the end 54. And then cumulative frequency is 4, And then in the second is 7, 4 plus 7, 11, 11 plus 4, 15, 15 plus 10, 25, 25 plus 8, 33, so on. At the end you will get the same answer, 54, and we had 54 people here, so our frequency is also 54, so these should be equal. So this was the raw data. We organized the data in the group frequency distributions, and on the basis of this table, we conclude that there are 10 people who has the ages range from 44 to 50 years of age. Right, so this is the group frequency distribution, and when we use the group frequency distribution, if we have a large amount of data, see this is the big data, so we can use the class limit. If we do not have big amount of data or large amount of data, so we do not want to make a class limit. This is ungrouped frequency distribution. There are only 1 2 3 4 5 6. There are only the ages of 28 children and who belongs to 10 to 15 years. So these are the class boundaries. You have to minus 0.5 here, add 0.5, subtract 0.5, minus, this is the boundary, this is the tally sheet, and this is the frequency. So on the basis of this table, we may say that there are 8 children who are 12 years of age, and there are 6 10 years of age, and so on. Right, so this is ungrouped frequency distribution. Now there are few examples to understand it. State the reasons why the frequency distribution is wrong. So see, the class width is not uniform, and I told you that class width, right, should be uniform, always should be uniform. Here 17, 18, 19, 20, 21, 22, 6, width is 6, 6, 6, but here width is not 6, 35, 36, 37, 38, 39. Here the width is 5. So class width is not uniform. That is why this frequency distribution is wrong. Second is why it is wrong. Class limits overlap. See, 4 to 8, 8 to 12. It should start from 9 to onward, and then here it should start from 13 to onward. If it is overlapping, suppose if there are two children who are 8 years of age, so where you will put, here or here? So this is wrong. Why? Because class limits overlap. And third is why it is wrong. A class has been omitted. See, after 102 there should be 103 and onward, and then it should be the fourth class. So one class is omitted. That is why it is wrong. And here you have to find out the midpoint boundaries width for the following classes. So the first class is suppose 34 to 38. So midpoint is 34 plus 38 divided by 2, which is equal to 36. And this is the boundary. You have to subtract 0.5 and you have to add 0.5 from the upper class limit. So this is 33.5 to 38.5, and the width is 5. And here 56 to 62, midpoint is 77. You have to add divided by 2. This is the boundary. You have to subtract 0.5 from the lower class limit. You have to add to the upper class limit, and then what is the width from 56 to 62 is 7. Right, so I hope everything is clear. If still you have any question, write down in the comment section, but please do not forget to subscribe my channel on YouTube, Sci My Academy, and thanks for watching it.